In question number 80, it says the first derivative of function f prime is given by x squared plus 1 times sine of 3x minus 1. And it asks for which intervals is the graph concave up. And we're talking about graph of f. So we want to know what's happening in the second derivative in terms of concavity. But we could also analyze this problem based on the first derivative. So I've graphed here the first derivative function. This is our x squared plus 1 sine of 3x minus 1. Now I'm going to need a graphing calculator for this because I need to be able to find the maximum points here. And so when I graph this, the way I analyze this is I can make my concavity charts because I can say that the change in the slope from slope of the slope graph is going to be relating to the concavity. So here I have a positive slope from negative 1.5 to negative 1.34. So that means that from negative 1.5 to negative 1.34, we know we have positive concavity going on. So that's relating to my f prime graph. In this next section here, we know it's going to be concave down. Okay, so it's sloping down, so that means that the derivative of the derivative is negative, so it's going to be sloping down from negative 1.34 to the next minimum point, which I get from my calculator. I need to do calc max here, calc min here, and that's going to be pointing down, so that means the second derivative is negative, which means concave down. In the next region, we know it's sloping up. That means the derivative of the derivative, or the second derivative, is positive. Okay, it's going to be positive all the way to 0.96. So we have concave up. And then from the next section, we know that it is sloping down again. So the second derivative must be negative. So it's concave down. So the answer is going to be between negative 1.5 and 1.34. And then from 0.24, so this should have been negative 0.24 to positive 0.964. So the answer is A. So alternatively, this could have been done using the second derivative as well. So if you thought right away that I'm going to use the second derivative, that's perfectly fine, because if we differentiate this graph, we're going to get 2x sine of 3x minus 1 plus x squared plus 1, and the derivative of the sine 3x is going to be 3 cosine 3x minus 1. Okay, so this derivative here is what I've drawn to the left. So this is my second derivative function. And what I'm looking for in this case then is the transition points for where it goes from positive to negative. So I'm looking for where the second derivative is equal to 0. And so I find my second derivative equal to 0. Equal to 0 at these points here. And again, they break up my regions into, I get 4 regions here. So I can do the same analysis. These zeros relate to these min and max coordinates, and then I can do my derivatives, or sorry, my concavities based on whether it's above or below the graph. So here in this region it's positive, so concave up. It's above the region here, so positive concave up. That's what I'm looking for. And then in these two regions here, it's concave down and concave down in this section here, which I see on my concavity chart. For question number 81, it says, during rainfall, the depth of the water in a rain gauge increases. It's increasing at a rate modeled by R of t given this function. So this is my derivative function. So this is my rate function. Just want to make sure that's clear. So that's my rate function. And the rainfall is measured in centimeters per hour. So again, this confirms my rate. So how much depth of water in the rain gauge increases from T of 0 to T of 3? Well, basically, I'm just want to integrate this. I want to find the area, which would the change in the rain, change in depth is equal to the displacement from 0 to 3 on my rate function, which is 0.5 plus T cosine of pi T cubed over 80 dt. Okay, now I cannot anti-differentiate this again, so I need to use this. I need my graphing calculator here. Okay, so I need my graphic display calculator. We cannot anti-differentiate this. So when I sketch this on my graph, I'm going to use my integral function, and I'm going to shade this from 0 to 3. Okay, and when I plug that into the calculator, I'm going to end up with the amount of rainfall from 0 to 3. It looks like it is 5.01. Okay, so that would be the amount of rain that has fallen, accumulated from 0 time equals 0 to time equals 3 hours.